na Esensya with Sir Alvin Miranda.
Good day, learners! Welcome back to my class. For this video, we are going to learn how to create and interpret tape charts and motion graphs. For our most essential learning competency, you should be able to create and interpret visual representation of the motion of objects such as tape charts and motion graphs. Are you ready to learn? Let's go! There are several ways of describing the motion of an object, such as explaining it into words or using equations to describe the motion mathematically. Other than this, one of the best way to understand motion is through the use of visual representations, such as graphs and diagrams. Viewing an object on a motion graph allows one to determine if an object is at rest, constant speed, speeding up, or slowing down. To help us picture motion easier, we can use a tape diagram or dot diagram and motion graph. Let's start with motion graphs. Motion graph is a visual representation that uses lines to show how two or more sets of measurements are related to each other. In this video, we are going to use lines in two axes, the x-axis and the y-axis. To make sure that the information is properly represented in a graph, a graphing paper is usually used. A graphing paper has precise squares and presents the information in an accurate manner. To understand how graph works in representing motion, let us try graphing the following data. The table shows the distance of the ball in a given time interval. To represent the motion of the ball using a graph, we need to plot this data. In this Cartesian coordinate, we have x-axis and y-axis. The time interval will be plotted on the x-axis, and the distance of the ball is on y-axis. Let us start plotting the data. At 0 second, the ball is at 0 meter. So, we are going to plot the data on this point. At 5 seconds, the distance of the ball is 5 meters. Here, we need to locate 5 seconds on the x-axis and 5 meters on the y-axis. Then, locate the point of intersection between 5 seconds and 5 meters. Correct! The data will be plotted here. Do the same on the remaining data. After plotting all the data, draw a line through the dots or points on the graph. Now, you created a graphic representation of the motion of the ball. The graph you created is an example of distance-time graph. We can use this graph to describe the distance of the object at a given time. Example, at 5 seconds, what is the distance of the ball? Correct, it is at 5 meters. The line that connects the dots on the graph is called a slope. The slope gives us an idea about the motion of an object. Now let us try interpret the slope in a given graph. If an object is not moving, a horizontal line is shown on a distance-time graph. The time is increasing to the right, but its distance does not change. It is not moving, therefore, it is at rest. The line on the graph is curving upwards. This shows an increase in speed, since the line is getting steeper. In other words, in a given time, if the distance the object moves is changed, it is accelerating. Observe the graph below and study its different interpretation. Aside from distance time graph, we also have speed time graph. Speed time graph is also called velocity time graph. The slope of the line on a velocity time graph is equal to the acceleration of the object. Speed time graph looks like distance time graph, so make sure to read the labels. Time is plotted on the x-axis, while speed or velocity is plotted on the y-axis. A straight horizontal line on a speed time graph means the speed is constant. It is not changing over time. Therefore, it has no acceleration. A straight line in a speed time graph does not mean that the object is not moving, unlike in a distance time graph. This speed time graph means increasing speed, constant or uniform acceleration, and changing velocity. This speed time graph means non-constant acceleration and increasing acceleration. This speed time graph shows decreasing speed and the object is decelerating. Another way of describing motion is by ticker tape diagram or dot diagram. This is where a long tape is attached to an object that is moving. The tape is threaded through a device that puts a tick or an impression on the tape at a regular time interval. This leaves a line of dots on the tape recording the object's motion. The distance between dots on the dot diagram represents the object's position change during the time interval. A large distance between the dots indicates that the object is moving fast, and a small distance between dots means that the object was moving slow. If the spacing is not changing or equal all throughout, it means that the object is moving at a constant speed and has zero acceleration. A changing distance between dots indicates changing velocity and acceleration. A ticker tape diagram that starts off with closely spaced dots but moves further apart as you go represents an object is speeding up and accelerating. A ticker tape diagram that starts with dots spaced further apart and gets closer as you go represents an object slowing down and decelerating.